Does Pluto have an ocean? The idea seems a little strange, but ever since New Horizons visited Pluto in 2015, there's been growing evidence for a subsurface ocean on this distant dwarf planet. And now two new studies explain not only how Pluto could have formed its ocean, but maintain it for billions of years to come. Welcome back to Launchpad. I'm Christian Reddy, your friendly neighborhood astronomer. The idea of oceans in the outer solar system isn't new. Several moons of Jupiter, Saturn, and Neptune are suspected of having oceans beneath their icy exteriors. Evidence includes giant cracks or fissures in their water ice surfaces, as well as geysers of nitrogen and water erupting as cryovolcanoes. These features require internal heat, enough to keep the water underneath the ice warm enough to form an ocean. At minus 240 degrees Celsius, Pluto is far too cold to maintain liquid water on its surface. But the New Horizons spacecraft returned images of long troughs called fossae. These fossae are thought to be tectonic fractures due to the presence of internal heat that would occasionally warm up and break apart the ice. Then there's the giant heart-shaped region called Tombaugh Reggio. The left half is a basin called Sputnik Planitia. Sputnik is thought to have been created in a large comet impact about 4 billion years ago. The impact gouged out a 1,300 by 900 kilometer basin that runs several kilometers deep. Over the next several millennia, the basin was buried underneath miles of carbon monoxide, nitrogen, and methane ices. But it's Sputnik's location on Pluto that has astronomers thinking that there's probably an ocean down there. Sputnik is centered on Pluto's equator. That suggests that there must be some extra mass there. To see what I mean, take a look at this video of a rotating ball of water on board the International Space Station. As the water rotates, low-density air molecules contract toward the axis of rotation while the greater density water bulges out at the equator. When you add some tea leaves and some orange peel, you get a little concentration of mass which bulges its way toward the equator where the ball is rotating the fastest. Not only is this a great demonstration of the conservation of angular momentum, but it's a really awesome way to make tea. So if there's extra mass underneath Sputnik, then it should have rolled its way around towards Pluto's equator. But Sputnik is also lined up opposite the side of Pluto that faces Charon. That puts Sputnik on the tidal axis, or an imaginary line between Pluto and Charon. Charon's gravity tugs strongest along this tidal axis, so it makes sense that over time Pluto would have rolled itself to line its extra mass up along this axis. But how does an impact basin get extra mass? If anything, impacts tend to remove mass. Pluto's interior is thought to consist of silicates mixed with water, surrounded by a shell of water ice and nitrogen ice. There's also plenty of organic compounds, tholins, and volatiles such as methane and ammonia. Sputnik is covered in nitrogen ice, so an early idea was that maybe there was an excessive buildup of nitrogen here. However, nitrogen is such low density that it turns out can't provide enough mass to roll Pluto around to its current orientation. But liquid water is much more dense than nitrogen. Perhaps it flowed from deep inside Pluto's core as the interior rebounded after the impact. That would create an ocean, but keeping it liquid for the last 4 billion years requires plenty of heat. Moons such as Europa, Titan, and Enceladus are warmed by tidal heating. As they orbit their host planets, tidal forces fluctuate, growing stronger, then weaker, then stronger again. This applies mechanical heat to their interiors. But Pluto is tidally locked to Charon, so there aren't any tidal fluctuations to continuously heat Pluto's interior. But radioactive decay would keep water in Pluto's core liquid. But if that water were to flow upward as a result of an impact, then the heat is going to flow upward with it and eventually escape to space. The result is that the ocean would freeze over in just a few 100 million years. But two new studies were just published this week that showed how Pluto can in fact maintain a liquid water ocean to this very day. We're going to learn about them in a moment, but first I want to thank my Patreon supporters for helping to make these videos possible. And I want to offer a special shout out to my newest patron, Perfaj Jensen. I hope I pronounced that correctly. Anyway, if you'd like to help support Launchpad Astronomy and keep this channel going for the price of a cup of coffee every month, please make sure you head on over to my Patreon page. I'll have a link here and in the description below. A team led by Dr. Cristina Dale Orr detected ammonia in Virgil Fosse, a series of ice-filled fractures in Pluto's dark red Cthulhu region next to Sputnik. The water and ammonia ice were likely deposited there via cryovolcanoes. Ammonia lowers water's freezing temperature, turning it into a kind of antifreeze. But ammonia is also very delicate and breaks apart easily when exposed to sunlight or charged particles from the solar wind. That means that the ammonia found in Virgil Fosse must have been deposited there fairly recently, within the last 1 million years or so. And that means that Pluto could have an ammonia water ocean underneath its surface ice. But this introduces a new problem. The Sputnik basin is covered in hills of nitrogen ice that range from 3 to 10 kilometers in height. If the water is directly underneath the ice, that would transfer just enough heat to get those hills flowing around as glaciers. Over time, say a few million years or so, those glaciers should more or less grind each other down and the basin would level out. But a new study by Dr. Shinichi Kamata and his team showed that a layer of Clathrates could explain the long-term survival of Pluto's ocean, as well as the rolling hills and valleys on the ice above. Clathrates are a mixture of gas and water ice molecules. In the case of Pluto, the gas is probably methane that was either delivered during the comet impact or bubbled up from the interior afterward. Such a clathrate layer would act as a thermal insulator, keeping Pluto's ocean liquid and its ice shell cold. Kamada and his team tested this idea out in computer simulations. They found that without clathrates, Pluto's ocean would freeze over in less than 1 billion years. But with the thin clathrate layer, Pluto not only keeps its ocean liquid since it formed 4 billion years ago, but continues to stay liquid for billions of years in the future. These results are encouraging, and it's amazing how much information has been pulled out from the New Horizons flyby in 2015. But to really know if there's extra mass under Sputnik, and indeed if there's an ocean, we would need to send a dedicated orbiter to Pluto. Such a spacecraft could measure Pluto's gravity field in great detail and map out where the mass is distributed around the planet. It could even use radar to probe the nitrogen ice layers at Sputnik, as well as the ocean and even the gas layer if it exists. In fact, the upcoming Europa Clipper mission will use these same techniques at Europa. Right now, scientists are working on a proposal to NASA to send a dedicated orbiter to Pluto. If accepted, it could launch in 2030, which would be the 100th anniversary of Pluto's discovery. Oceans appear to be everywhere in the outer solar system. Life requires liquid water, heat, and organic molecules in order to evolve and thrive. Pluto certainly has plenty of heat and organic molecules. The question is whether or not its ocean would really be habitable. It would certainly be a very cold ocean, so any life that does evolve would have to be adapted to an extremely cold environment. But you never know. It's interesting to think that there could be an ocean-bearing, maybe even a life-bearing world in the Kuiper Belt, but Pluto is hardly the only such world. Dwarf planets Eris, Haumea, and Makemake, even Quaoar and Sedna may host subsurface oceans. So much of what we now know about Pluto and what we're continuing to learn about this dwarf planet is thanks to the New Horizons flyby in 2015. That same spacecraft would then fly past another Kuiper Belt object just 3.5 years later. I have a video about the New Horizons science results of its flyby of 2014 MU69 Ultima Thule. So make sure you check that video out there when we're done over here. And if you'd like to join me on this journey through this amazing universe of ours, well, please make sure that you subscribe and ring that notification bell so that you don't miss out on any new videos. Until next time, stay curious, my friends.